Hi. Now that we have seen how to connect a single switch or even multiple switches to Raspberry Pi Pico W, let's try to understand what are the different types of inputs that can be given to Raspberry Pi Pico. Now, if you think that switches or keys are the only type of inputs to Raspberry Pi Pico or any microcontroller for that matter, then definitely even you know that that's not a correct assumption. There can be a number of different types of inputs that you may want to give to your microcontroller. It may come from normal switches, it may come from industrial switches like limit switch, it may also come from sensors like proximity sensor, inductive sensor. There are a number of different industrial grade sensors which don't give you 3.3 volt output. They will give you 24 volt output. And there are a number of different sensors available which can give you a small signal output also. Maybe you have a gas sensor module, maybe you have an IR module or a fire sensor module or a sound sensor module. There are just way too many sensors available which you can interface with a microcontroller. Let me just do a quick Google search, okay? So mic sensor or sound sensor, for example. Or you can simply use any or open any electronic store and you will see. So there is a sound sensor. It will work on 5 or 3.3 volt and it will give you the same 5 or 3.3 volt output. Now this kind of sensor, you have to make sure you have to check the voltages. You can directly give that to the Raspberry Pi's Pico's input pin. But let's say you have a proximity sensor or you have an industrial grade sensor, something like this. Let me open this up. Okay. When you go into an industrial environment, 24 volt is the norm over there. Okay. Now this is an inductive proximity sensor which senses a metallic object when it comes in front of it and generates a high voltage. NPN or PNP, depending upon the type of industrial sensor, it will generate an active high or active low output voltage. The point being, you cannot directly connect this kind of output to Raspberry Pi Pico because the Raspberry Pi Pico's pins are only 3.3 volt compliant. Even if you have a sensor for which you are connecting to 5 volt or which gives 5 volt output, then also you should connect it with caution, with care, with additional circuit. For this video, let's try to understand how to interface industrial proximity sensor or any industrial 24 volt sensor to Raspberry Pi Pico. And this applies to any other microcontroller as well. Now, there are two things which we do here. First is we need to bring this voltage down to a particular level. Second thing is we need to isolate the ground of Raspberry Pi Pico with the ground of 24 volt supply, because we don't want those 24 volt supply voltage fluctuations to meddle with the small logic level operations happening at Raspberry Pi Pico. So here comes the optocoupler. Optocoupler will be an integral part of your systems if you are doing any industrial design. Mind well, all this relates to industrial, and why I am saying industrial word so many times is because that's the biggest application area for these microcontrollers. And since I have spent my career installing these kind of systems into a lot of manufacturing places, that's why I give you this example. Now, what is optocoupler? It is no different than the transistorized switch that we have seen before. But the good thing is it gives you a complete electrical isolation. How? Let's see. There are a number of different optocouplers available in the market. I'm taking example of a very common one called PC817. It's a 4-pin IC. Just look at it. Giving a single look at the IC's construction will reveal what it does. If you see pin number 1 and 2 is just an LED and it has no electrical contact or no electrical relation wire going on to pin number 3 and 4. Inside the optocoupler, an LED will glow when you give supply voltage to pin number 1 and 2, and that light will fall on the base of this transistor, which will switch something on and off over here. So, if you have a 24 volt output coming from an industrial sensor, give that with a resistor to this anode over here, connect this cathode to the ground of the same 24 volt supply, and then you can do your switching circuit, or you can connect a resistor and 3.3 volt and ground here to accept that as a logic high or logic low. Let's look at this schematic over here. So, this is the sensor with 24 volt output. I have connected a 1K resistor, so it gives you more like somewhere around 24 milliampere of current passing through this LED. Most optocouplers will allow up to 30, 35, 40 or even 60 milliamperes of current for this LED. You can increase the value of resistor depending upon your particular need. What happens is when this sensor gives 12 or 24 volt output, the LED will glow. Make sure this ground is not to be made common with this ground. That will defy the whole purpose of using optocoupler. Now here, what is the switching circuit? It's very simple if you look at it. The collector goes to 3.3 volt. To the emitter, I have connected a resistor going to ground. So what happens is when there is no input on the LED, when the transistor is switched off, this pin will read ground potential or zero potential. And when the supply is given to LED, when the 24 or 12 volt output is on or available, what happens is this transistor will conduct, this 3.3 volt will appear across this resistor and so onto this GP0 pin. This GP0 is an indication. You can have as many optocouplers as you want and you can use any general purpose input output pin as you want. This is a very important lesson and this is highly needed whenever you are using any industrial devices, any industrial appliances to interface with your microcontroller. If you are experimenting with PICO just like me, then there are optocoupler modules also which are available for quick experimentation. But when creating a system, when creating a circuit, then you would have to refer to something like this. Once you make this connection, further things are easier. You will simply read them just like you read the normal sensors or switches. One more thing, I have by mistake made it 1K. It should be at least 4.7K. Because the purpose of this resistor is to simply give value or to give potential on this pin. We don't want high current to pass through it. Okay. So 4.7K or even 10K is good. If you give 10K here, then the current flowing is very low, which is in turn good. You don't waste much of your current. I hope you understand this one. I don't have an industrial proximity sensor to show it here, but the connection will be as simple as this. So if you have a sensor, you can experiment. I will try to create this experiment at a later stage and add the video. Thank you for watching this video.